Hello, I'm Mrs. Levine, and I'm going to be giving you some notes on 15:6 permutation. So I'm working on pages 3, 4, and 5 of your most recent packet. And there's an opener question on page 3 that we're going to talk about right now. So my stuffies are actually in my closet in my classroom, so that's not very useful right now. So we're going to call this little kitty cat Figment. So this is Figment. If you know Disney, it's an Epcot reference for the figment of your imagination. So we're going to call this little kitty cat Figment. This is a duck, so it's a duck. And then this guy here, it's a little lammy, but he's white, so we're going to call him Olaf. So my question to you is, how many different ways can I line up Figment, the duck, and Olaf? So we can put Figment first. I don't know that I really have enough hands for this. So I have Figment here, I have the duck, and then I have Olaf. But I could also switch the order and have Figment, Olaf, and then the duck. So if Figment is first, there are two ways that Olaf and the duck can be arranged. So now, what if I change it and I put Olaf first? So if I put Olaf first, now I can have Figment and then the duck, or the duck and then Figment. Okay, and now finally, what if I put the duck first? So if I put the duck first, I can have Olaf and Figment, or I can have the duck, Figment, and Olaf, for a total of 6 different ways that I can arrange my stuffies in my hands very clumsily. Okay, so let's go. I'm going to present now, and we're going to go to our notes and my document camera, and then you don't have to see me being all silly. All right, so here I am on page 3, and we're talking about permutation. So list all possible ways of arranging Olaf, Figment, and duck. So we would have, and before I do that, I just want to mention real quickly, I would highlight this at the top of your page. For permutations, and I'm going to get into this, order matters, and we are counting without replacement. So those are really the big ideas that you will want to reference, because that is pretty confusing once we do our next lesson the following week. All right, so back to Olaf, Figment, and duck. I'm going to have Olaf for O, Figment, and then duck. I can have Olaf, duck, and Figment. I can have Figment, Olaf, duck. I can have Figment, duck, and Olaf. And then finally, I could have duck, Olaf, Figment, and duck, Figment, Olaf. Now, my question to you is, do any of you know how we could write those 6 ways a different way? Okay, and the answer to that is we have something in math called factorial. So this is 3 factorial ways to line up our 3 stuffies. Okay, our 3 stuffed animals. So this is a permutation. So a permutation is an ordering of n objects. I went ahead and highlighted already. So in general, n factorial is n times n minus 1 times n minus 2, so on and so forth. So in this case, for 3 factorial, this is 3 times 2 times 1. 3 times 2 is 6. 6 times 1 is just 6. Okay, and we'll look at these in other problems. By definition, O factorial, I can't believe I just said O. 0 factorial is 1, and n factorial, and 1 factorial is 1. 0 factorial is 1. 1 factorial is 1. So we're going to do a few of these questions, but not all of them, because there are a lot of questions on pages 3, 4, and 5, and I don't want the video to be too long. All right, so I will kind of pick and choose. So right now we're going to go ahead and do number 1 and then 2A and B on this page. So number 1 reads, you have homework assignments for 5 different classes to complete this weekend. In how many different ways can you complete the assignments? And letter B says, in how many different ways can you choose 2 of the assignments to complete first and last? Well, especially now in these distant learning times, you have really gotten to decide when you want to get your schoolwork done during the day versus a typical school day when you have your courses and you have your exact lineup for when you have them. So this is kind of you doing your distant learning in your own choice. So how many different ways can you complete your homework? Well, you're looking at the 5 classes and lining them up, just like I did with the stuffed animal. So here the order matters. Anytime it's a lineup, you're going to be doing a permutation. So we are lining up all 5 assignments, and we're going to call that 5 factorial. So what that means, it would be 5 times 4 times 3 times 2 times 1. And you are, by all means, welcome to do that right in your calculator. 5 times 4 times 3 times 2 times 1. Okay, and I'm getting 120. Anytime you do something and it seems like, wow, isn't there a better way to do that? There often is. So, and that's beyond math. So I'm going to go into the math menu. And so I went into the math menu. This is math. And then probability is the one far right. So you can scroll to the right 3 times, or you can scroll left once. So I'm going to go left once, and now I'm in the probability menu. And the option that I want is the probability right now, number 4. And I just did something wrong. Because I do this a lot, because I did the 120 and then the factorial, and that's not what I want. So I'm going to hit clear, and that's fine, but you have to put the number in first. So I'm going to have to do 5 and then math, scroll to the left to probability, and I'm going to go down to number 4. Now I can type number 4 or use the down arrow to get to 4. And I'm going to hit enter, and there's 5 factorial. Then you have to hit enter again, and that gives me the 120. So you can do all of your factorial with your graphing calculator. Okay, and now the next question is a little bit different, because in 1A, I'm picking all 5 of the classes. In letter B, I only want to choose 2 assignments. So that's saying, you know, if I am a mean mom and I limit how many stuffies my child can sleep with. So imagine, instead of just having Olaf, duck, and Figment, we had 5 stuffed animals. And instead of letting my child have all of them, I'm only letting them have 2. And let's say they're very sensitive to their stuffies, so they want to arrange them differently each day. This is what they're talking about. So you are picking, you are starting with 5, and this is going to be a permutation. So we have 5 subjects, and we are arranging 2 of them. Okay, so what that looks like, the formula that I'm going to go over in a minute, is 5 factorial divided by 5 minus 2 factorial. So you have 5 factorial in the numerator, and then 5 minus 2 is 3, so you have 3 factorial in the denominator, and then you can go right ahead and list these all out. So 5 times 4 times 3 times 2 times 1, all divided by 3 times 2 times 1, and then you'll note these cancel, these cancel, these cancel. So really, when you have this, it's just going to be 5 times 4, so it's actually just 20. But what I just said a moment ago is you may use your graphing calculator for this. So this time I have to put the 5 in first. So I'm going to hit clear, and I'm going to take 5. I'm going to go back into that math menu, and then I'm going to scroll to probability, and you'll notice NPR is the second formula, so I'm going to type enter. So the 5 pertains to the N, the total number of objects, and the R pertains to how many you're actually selecting to use at that time, and that's going to be 2, and then you get the 20 from there. Okay, so that's our formula for permutations of n objects taken n. Let me say that again. Permutations of n objects taken r at a time. So this is the number of permutations of r objects taken from a group of n distinct objects is denoted by NPR, and then you have these formulas. So this is the one that I typically will see and use. I don't typically see the comma version. All right, so for 2, we are asked to evaluate 7P7. So we are taking all 7 objects. So if you think of this formula-wise, this is 7 factorial over 7 minus 7 factorial. Well, that's 0 factorial, which we defined a moment ago as 1. So this is actually just 7 factorial. So on your graphing calculator, you can do 7 and then math, probability, factorial, and you're going to get 5,040. Or I can do 7 math, probability down to NPR, and I get 7, and you're going to get the same number. Okay, that's going to be different for letter B, because out of the 7 objects, you are arranging 4. So this would be 7 factorial over 7 minus 4 factorial. So that would be 7 factorial over 3 factorial. And if you did this out, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 3 times 2 times 1. The 3, the 2, and the 1s would cancel, and that would just be this product. So I can do that on my calculator as 7p number 2, 4, and I get 840. And let's hope I'm not messing up here. I'm going to do 7 times 6 times 5 times 4, and I also get 840. Phew. Okay. And then this one here was 5,040. Okay, we can get that the two different ways as well. Okay. All right. So now I'm going to go on to the one thing that I just want to mention real quick before I go on to the next page is, had this been a smaller number, it would make it easier to simplify without the calculator. All right, let's go on to number 3. All right, so for number 3, there are 8, so I'm on page 4. Page 4, number 3. There are 8 movies that you would like to see. There are 8 movies you would like to see concurrently showing in the theaters. Wouldn't we all like to go do that? Letter A, in how many different ways can you see all 8 of the movies? So this is lining up all 8 movies. So it's really just 8 factorial. If you wanted to do it as it's a permutation where you're selecting all 8, you certainly can do it that way. But if you're just selecting all 8 objects, it really doesn't matter which way you choose to do that. So, and I just proved you that a minute ago. So I'm going to do 8 factorial. So I'm going to go into the math menu down to number 4. It's a little bit easier perhaps to use just the factorial when it's all the objects that you're arranging, okay? And 3B, in how many different ways can you choose a movie to see this Saturday and a different movie to see this Sunday? So now you're choosing, you are lining up 2 movies out of the 8. So when you're lining up 2 movies out of the 8, then we're going to do 8 permutations, selecting 2 movies to line up. So then this would be 8 factorial. I just mentioned a minute ago that sometimes this is pretty easy to do when the numbers are small. So 8 minus 2 factorial will be 8 factorial over 6 factorial. And then remember, this is 8 times 7 times 6 factorial, and you are dividing by 6 factorial. So I could write out 6 times 5 times 4 times 3 times 2 times 1 in the top and bottom, but that's kind of silly because those cancel. So this is just 56. If you want to do it always on the calculator, by all means, go ahead. You would do 8, and then permutations for number 2 of 2, and you get 56. So I get it either way. Go ahead and try number 4 and pause the video. For number 4, in how many ways can the letters of the word special be arranged using all of the letters, and then only 4 letters at a time? So there are no repeating letters in the word special. Each one is unique. So if you count, I have 1, 2, 3, 4, 5, 6, 7 letters. So that's going to be 7 factorial. And then this one would be 7 total. And we are selecting 4 to line up. And then you would go ahead and do your calculations for those 2. Okay, so then when you do that, we're going to get 7,040 and then the 840. Okay, so now at this point, I'd like to move on to page 5. So we're going to flip over. I'm going to go to page 5, and number 8 is asking, find the number of distinguishable permutations of the letters in A, full, B, summer, and C, difference. Now, full, summer, and difference are different from special because special didn't have any repeating letters. But if you notice, A, B, and C all do. So when you do letter A, you have to divide by the duplicates. So full is a 4-letter word. So you have 4 factorial. The L's are 2 are repeated twice. So you would divide by 2 factorial. So then when you do that out, you're going to just end up with 4 times 3, because the 2 factorials would cancel. That's 4 times 3 times 2 factorial divided by 2 factorial. So you're just going to get 12. In summer is a 6-letter word and is repeated twice. So now we're going to divide by 2 factorial. So let me show you how you do this one on the calculator. You would do 6 factorial number 4 and then divide by 2 factorial, which is just going to be 2. So if you can recognize that, it might be quicker than putting in the 2 factorial. You're going to get 360. So if I done 6 factorial, I could just take that and divide by 2. All right, and then finally, difference is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-letter word. Okay, and furthermore, there are a few things going on. So F is doubled, and then E has 1, 2, 3. So E is there 3 times. So you have 2 F's and 3 E's. So we're going to divide by the 2 F's, so the 2 factorial, and the 3 E's, the 3 factorial. Okay, so then I would do 10 factorial. Okay, divided by, and now I'm going to do parentheses. So 2 factorial, and again, that's just going to be 2, times 3 factorial. And I'm going to put those in parentheses in my denominator. Otherwise, you may want to do the product and then maybe store this number, or however you want to do it, but you're going to take this number and divide by the denominator, and I get 302,400. A lot of different arrangements of the word difference. So all the time when we're doing our permutation, you're doing an arrangement. It's always lining up, like I did with the stuffed animals, with the stuffies. It's always an arrangement. All right, so these examples from number 8, letters A, B, and C, are permutations with repetition. So if a set of n objects has n sub 1 objects of one kind alike and n sub 2 objects of another kind alike, and so on, then the number of permutations P, or the n objects taken n at a time, is given by P equals n factorial divided by n sub 1 factorial, n sub 2 factorial, etc. Okay, so let's just take a look at this for number 9, find A and B. So there are 9 players on a baseball team. Don't we all wish it was baseball season? For 9A, and how many ways can you choose the batting order for all 9 of the players? So this is a lineup of 9 players. So this is going to be pretty straightforward. It's going to be 9 factorial. I already know the answer to this one, so I'm not going to take the time to go into the calculator at this point. You should be pretty good that you can do that. You can verify that after. 9B, and how many ways can you choose a pitcher, catcher, and shortstop from the 9 players? So here it's positioning. So therefore, the order matters. Trust me, if you're a pitcher, you are not a shortstop. You're a catcher, you are not a pitcher. If that's your specialty position, they are very different positions. If you are a baseball player, yes, people can play multiple positions, but if you are not a baseball person, each one has a lot of different skills significantly. And so we're trying to arrange our team with those 3 positions. So because of that, this is going to be a permutation. The order or positioning matters. So that is why it is a permutation. So we're going to have n total players, so 9 total players, and the arrangement is taking 3 of those to line up. And then this is going to be 9 factorial over now 6 factorial. So remember, that's 9 times 8 times 7, which I can do 2 ways. Remember, I can always go to NPR in my calculator. Just make sure you put in n first, which is sometimes takes you a little while to get used to. Or I could have done 9 times 8 times 7, and I get 504. All right, so today we looked at ordering objects with permutation, and The next thing that we will do is looking at them without order. So it's a lot easier to do these when it's just the lineup and just the permutation. It gets a little bit more confusing once we mix it up between permutations and the next topic, which is combinations. All right, you're doing great. Thanks for tuning in. Have a good one.